Good morning, everyone. Good morning.
Morning, sir.
Okay, good morning. Good morning. And
Sir.
apparently, we haven't met for two sessions. And the reason for that is because first we had a meeting at school. And then the second reason is that there were some people out of power, many of our students. Because yesterday, BL has a was changing some of the lines and so forth. So I will begin with the taking the attendance. So if you're there, you just say you're present. Franceli,
Here, sir.
Franceli, Herman, Herman, Ashby, 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 Karen,
Present.
Damaris, Blades, Damaris Blades, Rachel Blanco,
Present.
Shanice Blanco, Shanice Blanco, Liane Cal,
Present, sir.
Linnell Cal,
Present.
Kaylee Kamal,
Present, sir.
Brittany Kamal,
Present.
Shanti Kano,
Present, sir.
Naveen Carrillo, Naveen Carrillo, Naveen Carrillo, Kiara Castellanos,
Present.
Emily Chan,
Present.
Alanis Colendres,
Present, sir.
Cherie Edwards, Cherie Edwards, Cherie.
Sir, excuse me, sir. I think that Sherry sent you an email because she told me last night that she was going to be absent for some class sessions because she was going to take something on vaccination, sir. And
Oh,
she was
okay.
asking me for your email, sir, and I give it to her. And I think she sent you an email to about
Okay, I will
concerning
check it.
about that, sir.
Okay, Shanti, thank you. Jency, Jency, Enamorado, Jency, Joanna Garcia, Joanna Garcia. Well, some people feel that I wouldn't come in today. They will just get penalized. Kiana Quillen, Kiana Quillen, Owen Martinez,
Here, sir.
Oziel Mendez,
Present, sir.
Vivi Novello, Aisha Novello,
Present, sir.
Jonathan Pook,
Present, sir.
Azali Ramirez,
Present.
Elvis Solis.
Present, sir. Good morning.
Okay, good morning, Elvis. And Jamile Tuyuk.
Present.
Okay, look like there's a whole heap of absences here. Like I told them, I am taking it once, and then that's it. The rest will just stay as absent.
If you call my name, sir, the right just now.
Well, I already closed. I think I call your name. Let me see. Herman, yes, you have been marked present. Okay, the rest that are not there will be absent. Last time we were still looking at the probability tree, and what I will be doing is getting back, because before I give you I want you to show you some of the short way of doing some of the problems, whereby we do not need to list all the different possibilities. So it will be by means of calculations. Okay, some problems whereby we will be doing by means of combination and permutation. I will do one of the problems first, long, and then I go back. We have done the probability tree, it shouldn't be that long. I want to get a good one. I think I need to go to the miscellaneous. I think it's somewhere around here. Let me check down more. Oh, that's 4. So it has to be. I'm not seeing the problems that I want. Maybe it's the one before we do the permutation. Yeah, I think one of these here. Yeah, this is what we're gonna get into. Yeah, let me look at one of these problems. I didn't put this one, but because I want to have showed you before I introduce the other topic. So let me show you how this is being done. And remember, I need the input because by now, some of you, when I look at your tests, the first question up to question number 3, 4 was okay. Number 5, the one with the lucky dip. Many of you messed up that problem badly. So I will be showing you what I'll be sending you the solution to show you how that problem should have been done. Some of you messed up that problem so bad. And all of those are independent events. I don't see why some of you should be getting having problem with those. Because there you are dealing with 3 different boxes, and each of the boxes have 2 different items, and they told you the number of items each box has. And so drawing out of one particular boxes, then they are independent event, because if you're drawing from box A and then you need to draw from box B, whatever you draw from box B will be independent of that what you draw from box A. It has no effect on each other. Absolutely no effect. Are you hearing me?
Yes, sir.
I see some people are mute.
Yes, sir.
Anyhow, okay. It says here that vehicle approaching a crossroad must go in one of 3 directions: left, right, or straight on. Observation by traffic engineers show that of vehicles approaching from the north, 45% turns left, 20% turns right, and 35% go straight on. Assuming that the driver of each vehicle chooses direction independently, what is the probability that of the next vehicle approaching from the north A, all go straight on? B, all go in the same direction. C, 2 turn left and 1 turns right. D, all go in different directions. And E, exactly 2 turns left. The easiest way to have done this problem is to have used a tree diagram. However, I told you that I will be doing it by means of the other way, using probability theorems. And then from that, we're going to be looking at arrangement, whereby we see that we could merge these problems into one. So what's the first thing that we need to do here? What is the first thing? Whenever we solve any probability problem, what's the first thing that we need to do?
Extract our event.
Okay, we extract our event. So we can use a capital L to represent the vehicles as goes left. then we can use a capital R is the event that the vehicle goes right. And we can use a capital S for the vehicle that goes I don't really like to use the capital S because we use it for a sample space. But in this case here, we won't be using any, we know the sample space would have been 100% because looking at the one that goes left, 45, 20, and 35, if you were to add those together, you should get 100%. So we know then that the universal set would have been, so to make this easier for you, we're gonna be using S for those vehicles that goes straight. Now remember I told you I need the input. So what else can I write here before we start doing the calculations? It said that 45% turn left. So which means then the probability of L is equals to 0.45. I'm not telling you. Like I told you, some of you will be needing this, trust me. And even if you need that point and I see you are not participating the way you should, I will leave you with the D+. So what will be the other one there?
The probability of right.
Okay, probability of right, good. Will be equals to
0.20.
0.20. And the probability of going straight is equals to
0.35.
0.35. Okay. So are there any questions?
Not as yet, sir.
What happened?
Not as yet.
Okay. So which means then the probability of L intersecting rather independent event R intersecting S. What will this be equals to? In fact, sorry, I have the wrong notation. Union and union. So what will that be equals to?
100, sir.
100, which is 1, right? Since you are dividing everything by 100 already, so that will be 1. Everybody agrees?
Yes, sir.
Okay. Now let's look at our first thing that they want us to look at. They said that R goes straight on. So we are looking at A, that all of them goes straight on. So what will that be? So what is that? So what will it be? It said that, remember, there are only 3 vehicles. They can either go left, right, or straight on. I mean, those are the direction. We are not saying vehicle direction. There are only 3 directions: left, right, and straight on. So it said here that assuming that the driver of each vehicle chooses direction independently. So they're asking, what is the next vehicle approaching from the north? I'll go straight on. So remember, the vehicles, the direction of the vehicle will be independently, but that doesn't mean that they cannot go in the same direction. So what will it be? Students, I need your cooperation. What will it be? Student, looking at the information that we have extracted from the problem, I only see the probability of S is 0 for any vehicle that goes straight on. So we are talking about the first one going straight, intersecting the second one that goes straight, intersecting the third one that goes straight. They are independent of each other. So this would be equals to the probability of S times the probability of S times the probability of S. Now looking at the going, this is for them to go straight on. So I will just copy and so the probability of each of these going straight on, we have the probability. What is the probability of each of them going straight on?
0.35, sir.
Okay, 0.35 times 0.35 and then times 0.35. So what will that give us?
0.042875.
Okay, let me. Okay. So run that value by me again slowly.
0.042.
0.042
875, sir.
875, and I hope the others are following.
No, sir, that exact.
No, it's exact. I hope the other students are following.
Okay.
That's what I'm saying. Okay, we are looking at part B now. I'll go in the same direction. So what that would have been? They said that
There wouldn't be the probability of S in the union of L and the union of R.
okay, but it said here, I'll go in the same direction, but like what you're saying. So this will, let's call it the probability of A. Is the event that I'll go in the same direction. So they can all go like what you mentioned. They can all go left, intersecting L, intersecting L, meaning that two of them goes left. Plus, we could have two of them going right, and they are going in the same direction. So we have the probability that it's go the first or whatever, right, intersecting right, intersecting right. Then we have another option, which was the last option that we just found, the probability that they all go S intersecting S intersecting okay, like that. I said I'll go in the same direction. So if I'll go, we're talking about three vehicles, the next three vehicles. So if they're going in the same direction, so they can all go left. They can all go right, and they can all go straight on. Are there any questions? Are there any questions?
No, sir.
So okay. What will go there?
0.
I'll go left. 0.45.
45.
The other one will be And the other one will be, then the next will be simply 0.20. So this one will be 0.35. Okay, like this. So the probability of A, okay, when we multiply 0.45 times 0.45, 0.45, what do we get?
Sir, 0.091125.
Like that?
Yes.
Okay. And the one for the, what will it be?
0.08, sir. 08.
0.008?
Yes, I got that.
Okay. And then we have the other one, which we already found, which is 0.042875. So when we add these together, so what will be the probability that they all go in the same direction?
0.142, sir.
Right now, just hold that value for me. So the probability of A is equals to
0.142.
okay, 0.142 exact, right?
Yes, sir.
Okay, good. Okay, so that was part B. They were asking, oh, I didn't even label it. I have to differentiate it. This is part B. Okay. That's part B. Now part C is asking us 2 turns left and 1 turn right. So let's call that the probability of B. Two turn left and the other turns right. Now this is where the combination and permutation will be coming in. You understand? And also in this case, this could have been they are going in the same direction, meaning then I will show how this will be done. When we use the permutation combination. So the probability of B will be equal to 2 turn left and 1 turn right. So that will be probability of L intersecting R. Everybody agrees? I'm asking. Student, I'm asking a question.
Yes,
What
sir.
would be another option here?
Wouldn't it be R intersecting L again?
Yeah, but the best you go alpha when you do this, that will be the last option we're gonna be looking at. But best you look at, okay, we have the two of them, we put the LRL, okay? That could be the other option, L, and then the one that you mentioned a while ago will be the last option. But it doesn't matter how you listed it, it's still correct, but so that you don't make mistake, so you use the first L, and then from there use the L and the second letter and the other one and things like that, so that you do not get confused, okay? So this will be L, and then the other one will be like what you said, probability of, then we're gonna be having R intersect L intersect L. Are there any more options? Are there any other options or any other combination, or that's it?
That's it, sir.
Okay, that will be, that's it. Now, I will be using this here to expedite the process. Okay, so the probability of B, which means then that 2 goes left and 1 goes right. So the probability of going left is 0.45. So, and the probability of going right is 0.20, right? So this would be remember left is 0.45, left, and then right. The other one will be left, which is 0.45, and then the other one will be right, and then the other one will be left, which will be 0.45. Then here we have right, which is 0 point. Some of you are not even helping. So that's right, and then we go left, which would be 45. Okay, start giving me some values.
Sir,
Yes.
it is 0.0405.
For the first set,
Yes,
0 point.
0.0405.
Like that,
Yes,
plus the other one.
Sir, it will be the same, no?
yes.
Yeah. I just want you to have noticed that. So when we get into permutation, then you see why that works. Plus 0.0405. And then when we add that, what do we get?
Sir, I got 0.1215.
Yes.
Just hold the value there for me. Probability of B equals, what will it be?
0.1215.
0.1215.
15.
Okay, the other one now is asking us, let's see, R goes in different direction. R goes in different direction. So R goes in different direction. That's D we're looking at. That R goes in different direction. So let's use that as the probability of D. So which means there are different options, the probability that the person can go. Let's begin with the basic that they have. L intersecting R intersecting S. Go in different direction. One go left, one goes right, and the other goes straight on. Now, this is whereby, let's see, I know this will give us, because 3 factorial is 6. So it's gonna give us 6 different combinations. So we're gonna be listing all 6 of them. Let me just copy this. To expedite the process, so this will be paste plus paste plus space, plus, space, plus, let me smarten this a bit because I want everything in the same line. Okay. Now we're gonna put the option because we are not, those are, I just put it in to get. So that could be L intersect
S intersect R.
mhm, like that. Now we can start with the R because we have finished it, the L. Now let's begin with the R here. Now we don't have any more option with the L, right? So we're
No,
gonna
sir.
look at the R. So we begin with R, so we could have a R intersecting L, intersecting straight on, right?
Yes, sir. Then the
And
other
then,
one, R intersecting S intersecting L.
then we can have R intersecting S and L, right? Everybody agrees?
Yes, sir.
Then we can begin with the S now. The last variable, that's the way to usually use the first one here. So we could have S intersecting L intersecting R. Then we can have S intersecting R intersecting L. Everybody agrees?
Yes, sir.
Okay, now you will notice because then to put in the values here, it's gonna be tedious. So this is the way that I recommend. So you find for each of these first. So this will be equals to, we do them piece. And let us put in the values. So turning left was 0.45, turning right was 0.20, and going straight line was 0.35, right? Everybody agrees?
Yes.
Yes, sir.
Okay, so this will be equals to what?
0.0315.
0.015.
315.
Okay,
15.
15. Then we're gonna be doing this here for each of them. Copy. Okay. Left will be 0.45. Straight down will be 0.35. And then right is 0. Which will still give us the same value, right?
Yes,
We will
sir.
get 0.0315. Now, we notice that for all of them in this case, we're gonna be getting that. So all that I will do now, because I want to expedite, I won't be doing because I notice that time is going. But the probability of D remember, you need to have done that for all 6 of them. Like when you're showing me you're working the long way, you have to show me the rest. I just did 2, you need to have shown me the other 4. Are we clear that?
Yes, sir.
Yes, sir.
Okay, so this will be 0.0315 plus okay. So when we add all of those together,
Sir, the answer would be 0.189.
okay. Okay, everybody agrees to that? Because it's now 9. Everybody
Yes, sir.
agrees to this?
Yes, sir.
Okay, so have a nice weekend. You will notice in now that, but I still, since you won't be using, I still have to do the comment, but I will be sending you the work. This one isn't complete either. So have a nice day. And a nice
Thank you,
weekend.
sir.
Okay.
Thank you, sir.
Bye.
Thank you. Be safe.
Okay.